What's up my friends, so in this video we are going to build our own echo command line Linux using C and assembly. Okay, so first thing, let's see what is this echo command. But before starting, I made the catch command using C and assembly and it's in my channel, you can see it if you want. Okay, let's continue. So as we know, echo is a command that prints what you enter to it. For example, echo hello world, and this text it will return it and print it in the std out. Okay, for example, if we entered a long argument or multiple argument like this, it will print them all with space between them. Okay, so this echo command have some properties. One of them is redirection, so you can redirect this text or this all input to a specified file just using this greater and just by using this greater than operator. You can redirect this all inputs in a specified file. For example, file, here there's an information echo, it's gonna search for this file in this directory. If it finds it, good, it will write all this data in this file. Else, if echo didn't find this file in directory, simply it's gonna create this file and write this data into it. So let's see. So we are going to see that we have this cut file and we did cut for this file. We are going to see we have our data. For example, let's do let's remove this and just keep the hello world. So we're going to see cut file and we have here our hello world. So this is one from the properties, so we're going to implement in our own echo. Okay, also we have some flags. So for example, we have echo, and let's remove this redirection, so like this. So as you can see, if we did cut minus e, so we're going to see that there is a new line in the end of this output. Okay, so if we did the minus n flag, this new line we are not going to see it because it will remove this new line from the end of the output. Okay, this is a flag that we are going to implement in our echo. We have another flag which is minus e, which take the role or the responsible of executing the escape sequence. For example, let's see, we want a new line between these two words. For example, let's do \n and the code right here and the code also right here. We are going to see, for example, let's remove this cut. We are going to see that there is a new one, for example minus t for tab. We are going to see that there is a tab, and without this minus e we are not going to see this tab execute. It's just gonna be right. For example, if we remove this minus e and this double quote, I found that this \t, which is the tab, is gonna be also executed, as we can see. So as you can see, if we remove the minus e and just we did hello /t and word, it's not gonna be executed. Okay, so in this video we are going to implement the redirection. So redirect this input to a specified file and create it if it doesn't exist in this directory. Then we are going to implement the minus e flag and the minus e flag, sorry, here minus n flag and here minus e flag. Okay, so let's get started. So we're going to do ls. Here I have a C version and assembly version. Okay, so I'm going to start with C. So here, and as you can see, I have a make file like this, simple make file to compile my code. Then vim main.c. I have here my important header files. So let's get started. I'm going to create my int main like this. Okay, and I need the argument. Okay, so char pointer to pointer av. Now we are going to start from the beginning. We are going to just handle like just printing the argument that we pass to this command. Okay, so like this we are going just to implement this first step. Okay, so vim main.c, we are going to do int I equal to 1. Why 1? Because we are going to start the loop from 1, because we are going to exclude the name of the program. The name of the program is not gonna be printed. Okay, then here in g to loop on the string inside this argument vector. Then we are going to do like this and a while loop right here. Okay, so we're going to do e++, and here the condition when the av does not equal the null pointer, because in every 2D array we have a null pointer. Okay, so as you can see, we are going to do, because here there is because here it's an array of pointer, so the end is going to be a null pointer. Okay, so here we are going to do g0 like this, and we are going to do a while like this, and while also the AV of index I inside of it, or inside of this string, when is not equal to the null terminator, because each string have in the end the null terminator. So g++ like this, and we're just going to print it like this. So we have here 1 and address of AV of index I of index G, okay, and 1 like this. Okay, so, and as we see, we are going to print the string, but we need for each argument a space. So we are going to do write 1, so we are going to do write 1 and a simple space right here, so 1 like this. Okay, now let's do make. I guess I have a problem for the argument counter. Yes, I need to void it. So here we are going to void the argument counter, so we're going to do AC, because when we don't use the argument counter we need to void it. I am going to do a comment right here which voiding the argument counter when we don't use it. Okay, good, let's continue. Bro, come on, make. Good, now I have my echo file, so we're going to execute it. So as you can see, it prints the arguments. Okay, but here there is a problem that I guess you will not see it, because as we said, in each program we print after it the space. So here is space, here is space, and here also we will find that there is a space, but we are not going to see it. So we are going to handle this problem by doing an if condition. So we are going to do an if condition. If the I plus 1 does not equal the argument counter. So here what we need to do, we need to remove this void argc. Okay, so let's, bro, come on. Okay, let's do like this, and let's remove this. I'm just going to do a comment for you guys like this. Okay, so just a comment. Good, now let's see. So make, and good, for example, long. Good, so now successfully we end the first step in our journey in making our own echo. So now the next step is doing the redirection. So for example, what we need to do like this, and enter this greater than operator and the name of the file. So we need to redirect all this input into this file. Good, now there is a problem. As we can see in the write function, we need to write into this file. The open, it's so easy. Here's the problem, we need to write to this file, but here as we can see we have one is the file descriptor of the stdout, not the file descriptor of the file that we are going to open. Please, if you don't know what is a file descriptor, it's just a number that indicates or point to a specified file. Okay, so 1 is for the stdout, which is what we see right here. Okay, good, now we have a problem. We need to make this one, if there is a opened file, point to the same opened file. Okay, so to make this we need a syscall called dop2. So this dop2 system call in C is used to duplicate an existing file descriptor to a specified new file descriptor. So as we said, if you want to see, so as we said, we are going to make the one point to the opened file descriptor if there is an open file descriptor, if there is an open file. Okay, so let me explain in the whiteboard. Okay, so as we can see, 0 is for the stdin. Okay, and let's do like this and like this. Okay, like this. So here we have the stdout, and here the std error like this. Okay, so let's, I am sorry for the writing. Okay, so these are defaults. Okay, so when you open a file, it will check the next available number. For example, if the next available number is 6, so this open file is gonna check the number 6. So what you want to do, we want to make this one point where this 6 point to, because this file descriptor are just a pointer or an entry to the file does. Okay, so we want to make this one when we open this file, point where this file descriptor is point to, and by using this dub2 syscall we can do it. So the dub2 syscall, it taken two arguments, or let's say two arguments. There are two integers, and here we have the old file descriptor. Let's make it too longer like this, and here the new file descriptor. Okay, good. So the old file descriptor will be for example here the 6, and the new file descriptor is gonna be 1. So what will happen under the hood, it will make this one not pointed to the std out, so the one will not longer point to the std1. Okay, to the std out, sorry, it will point where this file point to. For example, is point to the file dot txt like this. Okay, so like this is the work of the dub2. Alright, so this is what we are going to do. We are going to loop on this argument, excluding this argument which is the name of the program. We are going to loop on all these arguments. Then when we are going to find this operator, we are going to stop right here, and we are going to take the next argument, which will be the file, and we are going to call the open syscall that we used in the previous video in the cat command. Okay, then we are going to check the file descriptor and pass it to the dub2 syscall. Then the one will point where this file descriptor number point to, which is the file. Okay, so let's do it. So we are going to do vim main.c, and we are going to do a while loop right here. Okay, so we are going to do a command looping on the argument until we find this operator greater than. Then we are going to take the next argument, or we are going to open the next argument and between parentheses the file. Good. Now let's do it, a simple while loop like this. So while the av of index I does not equal the null pointer, then here a simple I++. Okay, then there is the work. We are going to do if let's see the av of index I of index 0, because as we know this operator is length of 1, so we just need to do av of index I of index 0 is equal to what is equal to this operator. Then what we are going to do, let's do a tab here and also a tab here. Okay, good. We can do like str comparison, but let's make it easy for us, and in the future we are going to add str comparison right here. Okay, now let's continue. So when we find this operator, we need to call the open syscall. So we need to create here a variable called fd equal to 0, where we are going to store the file description. Good. So here fd is equal to the open syscall, as we know. So the open syscall will be the file name. So the file name will be after this operator. So av of index I plus 1. Good. So here we need to pass the flags. So let's search for the flags. Open syscall flags and modes. Okay, so as you can see here, we will need the right flag, okay, and the create flag. So here, because here So because here, if the file is already in the system or in our directory, sorry, then we are going just to write to it. So else, if the file doesn't exist in this directory, then we need to create and write to it. Okay, so here we need the mode. So here we need the mode, which is the permissions for this file. Okay, so we are going to copy the permissions like this. Okay, good. Now let's continue. Okay, so this is the file descriptor. We need to do a check if the file descriptor failed in opening this file. If less than 0, okay, like this, then we're going to print, or just let's do printf. Okay, printf, then we're going to do failed in opening this file. Good. Now let's see. Okay, so we're going to do make. I don't have any problem, and for example, let's minimize this text like this, and our operand between double quotes, because if we remove this double quote, this operand is gonna be a shell specifier. Okay, so it will be executed by the shell before us. Okay, so we need to do this quotes right here. Okay, for example, the name of the file. Good, there is no problem. So let's, for example, else print the file descriptor. For example, let's do like this, print here %d and fd like this. Okay, so make and the same input 3. So as we said, the file descriptor will check the next available number. So the next available number now in the system is 3. So for example, if another program wants also to open a file, it will check the number 4, and also another program, it will want at the same time to open another file, it will check the number 5, and so on, and it will check the next, and so on. The operating system will check the next available number in this file right here. Okay, I hope you understand this part. Good. Now what we need to do, we need to make the number 1, which is the std out, not pointing to the std out. We need to make it to point where this 3 points. So this 3 is a pointer to this file. Okay, so we need also to make the 1 point to the file. Okay, so let's do it by using what? By using the dub2 syscall. So what we're going to do here, let's remove this printf and let's do dub2. So dub2 right here, and as we said, we need to pass the old file descriptor, which is for the opened file. So fd and 1. So easy. So let's make a comment right here. For example, let's do a redirection the 1 file descriptor, the 1 fd, from pointing to the std out to point where this open fd point to. Good, I hope you understand this part really well. Okay, so by the way, here we need to stop the while loop. Okay, and we are going to do break. Okay, because just this is the work of this while loop. Okay, so this while loop is gonna be executed normally. Good, then it will go to this while loop. So we have here the 1, and as we said, the 1 is point to where this file descriptor is pointing to. Good, so this is not going to print it in the shell. No, it's gonna print it or write it in the file that we opened. And let's see if this true or false. Okay, so let's save and do make. Okay, we have a problem. Okay, so let's remove. Yep, I have just a syntax problem right here. So make again and clear. Good, we don't have nothing in the std out. So let's do cut and the file. So as you can see, there is a problem right here. Okay, so the problem, what is the problem here? The problem that the I looped until it reached this operator, and the I is continuing right here. So this is the problem. We need to set the I again to 1. So I will equal to 1. Good, now let's continue. I is equal to 1. Now let's do make, and good, now let's do cut the name of the file. So here we have hello world and the redirection operator and the file, but we don't want this redirection operator and the file. We want just the input that we entered for this echo, because this is the normal behavior of the echo command. Okay, so we don't need to loop in this while loop until we find the null pointer. We just need to loop where this I stopped. Okay, so before setting the I to 1, we need to create a variable right here. So int end equal to 0, then the end will equal to what? Will equal to the I. Then here the loop is gonna start from 1 until the end. So I, while the I is less, what is less than the end, setting the end of good. Now let's see it again. Clear, make, and good. Now cut. Okay, we still have the problem. Okay, so we have end while the I is less than the end. Good, I plus plus. Okay, so I is equal to 1. For example, let's print the end to see. Let's print the end. Okay, so printf %d and the end. Good. Now let's do make again, the semicolon like this here. Good. Make and echo, then cut. Alright, so hello world tree. Okay, so here we have tree. So 0 1 2 3. So basically the printing in this file need to stop right here, but where is the problem? Okay, I don't know where is the problem. So let's remove this printf and let's run it again. So let's save this file and do make also again. Okay, cut. Yep, the same problem. But here, why tree? Where this tree came from? Where did tree come from? Okay, let's see. We don't have no number 3. Let's do make again. Make clean. Okay, good. Now let's do make all and cut the file. I have 3. Okay, let's use the GDB to see where is the problem. So my echo like this and lay in, enter. Yep, I need to do the flag -g. Okay, so sorry, I'm gonna do vim make file and the flag -g for the GDB. Okay, good. Bro, come on. -g and make. Okay, good. Now let's do GDB and lay in, enter. Where is the C code? I don't see it. Okay, let's do vim make file. Alright, let's do make clean, then make and GDB. Okay, now we have -g. Okay, so lay in. Alright, this is our C code. Then we're going to break at the main, then run, for example, hello world and the operator, then the name of the file, for example, file. Good. Now let's see what is going on here. Okay, so and here, as you can see, it will loop until it finds this operator. Now it found it. Now we can see the ft is 3. Now we can see n. So here the dub to make it work, make the 1 point where the ft point 2. Then we're going to do a break. Okay, so let's print the I is at 3. Okay, so here end is equal to I, so p is equal to end, p end is equal to 3. So here it's gonna loop until it reached the end. Okay, good. Now let's do it. And okay, is printing right here. Good. So pi is equal to 2, then and continue. So here it's printing the word. Okay, good. Where is the problem? I don't know where is the problem really. Let's remove this file, for example, and remove also nothing. Okay, and let's do make. Good. Let's do echo like this, file or txt for example, and let's cut. Good. Now let's do another test, for example long data and multiple argument like this. Here is the problem. No, let's add a space right here, sorry. Good. Let's do cut. Okay, good. All the input that we entered, expect the name of the program and the operator and the name of the file. Good. I hope you understand this part. Okay, now let's continue. Now we just have to implement the -e flag and the -n flag. We're going to start by the -n flag. It's a simple flag, as we said. It removes the new line that we print, that we because just to know, when you do echo for example and this argument and you hit enter, so the enter is also saved right here and you don't see it. Okay, so we're going to remove it. Okay, good. Now let's do it. So clear and vim not make file main.c. Good. So here a simple condition, we need to make another function, and this function, what we need to do, it need to see, for example, if there's a flags in the beginning. It's just, it will search for the -e flag and the -n flag. If it found one of them, it have a specified variable and it will set this variable to 1, because this variable, they're going to work like a flag. Okay, so for example, when we are going to find the -n flag, this variable, for example new line flag, it's gonna be set to 1. Good. Then it will stop right here. Here you need to know something. The -n and -e flag need to be properly after the name of the program. For example, if we have something like this, for example we have hello and -e and -l, this -e and -n they will not work because there is something behind them, so they need to be after properly the name of the program. This is the case, or this is the condition. Okay, so let's start to do it. So vim main.c, I'm gonna call a function right here before printing this argument. Okay, so a call will be right here. So for example check flags function. Okay, so check flags function. Okay, so we need to create 2 variables to set them either to 0 or to 1, depend if we find the flags or not. Okay, so we have here int new flag. Okay, it's equal to 0, and here int new escape flag is equal also to 0. So this, I'm gonna pass them to this function, which I'm going to create right here, and it will return an int, and I'm going to say to you why it will return an int. Okay, so flag like this, and good. So it will take the argument vector, so we're going to pass the AV. Then I'm gonna pass the address of these 2 variables, because what? Because we need to change the value of these variables right here from this function. So we're going to use pass by reference. Okay, so the address of the new flag right here, then the address of the escape flag right here. Okay, good. Let's continue. So here we're going to take a char point to pointer params like this, then here int pointer new line ptr, then here int pointer, and here int pointer escape flag ptr. Good. So the escape is here and the new line is here. Okay, good. Now just a simple while loop. So we have here int I is equal to 0, then okay, like this. So a simple while loop, we're going to loop. Good. So here, while the params of index I does not equal the null, so like this. And here I'm gonna call the FTS the star comparison. Okay, so I plus plus. So here I'm gonna call the string.h. Okay, so include string.h. Good. So I'm gonna do just comparison. I'm gonna compare if this param is equal to minus n or minus e, and depend on each time I'm gonna set a variable or I'm gonna set a pointer to one or not. Okay, so if condition, if the params not if the str comparison of params of index I and the minus n is equal to 0, because how the str comparison is equal, if this string is equal to this string, then it's gonna return 0, else it's gonna return either a value bigger than 0 or less than 0. Okay, so I'm gonna take the pointer to the new line ptr like this, so the new line ptr, and I'm gonna set it to 1. Good. Then I'm gonna do an else if. So the else is gonna be like this, else if the str comparison of the params of index I, for example, if this condition is false, so let's do some spaces right here. Good, and space right here also. Good, is equal to the minus e. Okay, minus e is equal to 0. Then we are going to set what? Set the escape flag ptr to 1. Sorry. Good, to 1. Else, what you need to do, so here, for example, if we start looping and we find that the first parameter is not one of those flag, so here we are going to stop right here, because even we find that there is a flags in the, for example right here, this flag will not be activated because they are not after properly the name of the program. This is why. Okay, so here so here we are going to do what? Break. Okay, good. So we're going to get out from this while loop, and here what we need to do, for example, the use case, the correct use case where the flags they are correctly after the name of the program, we are going to loop on this. Then we are going to set the variable escape flag ptr to 1. Then we are going to loop on this parameter, and we are going to find that is equal to minus n. Then we are going to set the new line flag to 1. So here the I will point right here in this word. Okay, so here it's like where the I is stopped, so we need to return this I to the previous while loop. Okay, so I'm gonna show you. For example, here the I is pointing toward, so here the I is not gonna start from 1, so we don't want to print the minus n and the minus I, so the I will equal to the return I that will return from this function. Okay, so I is equal to the I that we are going to return right here, so return I. Good. So now let's try to print the argument. So for example, let's do print, so print like this, new line flag like this, and %d new line flag. Okay, so new line, sorry, just let's do new flag. Okay, then we are going to do a new line right here. Good. Then we are going to do what? We are going to do copy and paste right here. Good. Now here we have what? We have the escape flag. Okay, so the escape flag right here. So escape, let's just copy it right here. Escape flag. Okay, sorry. And now let's do make. I think I have some problems, so I need here what? I need the semicolon. Okay, so like this. Now let's do, come on bro. Okay, save and make. Good. Now the flag is equal to 0, then is equal also to 0. Good. Why? Because the -e and -n are not properly after this name of the program. Good, good. Now let's try to make them properly after the name of the program, like this. Good. Now there is a problem here. Why the new flag is equal to 0? Alright, there is a problem right here, I guess. Okay, let's see where is the problem. I print them after the flag, the check flag function. Good, there is a problem, I guess. Okay, there is no problem. We're just going to use the GDB and go step by step and see where is the problem. Okay, LAN equal and break at the main, run -n -e. Good. Then for example, hello world. Good. So we're going to do n continue. So here there is no file. Okay, so the I is okay. So let's run again. I need to go inside this function iMessage. So -n -e, haha, for example. Yes, and continue. Let's scroll down right here. Good, let's continue. Okay, so S, I guess SI or just S. Okay, just S. Okay, and so the first parameter, where is -n? So this should equal to 0. But why? The str comparison, the params of index I -n. Why? Params of index I is equal to 0. This is the problem. We need to start from 1. Okay, we need to start here from 1. This is the problem. Okay, so let's see. Let's do make. Good. As we can see, the new line flag is equal to 1 and the escape flag is equal also to 1. Good. Now let's continue. For example, let's do for example just the -n flag. Okay, the new line flag. As you can see, this is the problem. The escape flag is also equal to 1. Why? Alright, again GDB LAN and break at the main, but enter break at the main, run, and -n -e. For example, we have n, continue looping, and let's go inside the function. Okay, so first thing we have here is the -e. Sorry, I need to do just -n. Okay, so run -n, for example. Okay, so new line. Okay, let's continue. Good. S. Okay, just we have the new line flag. Okay, so let's continue. Good. Now this new line ptr is gonna set to 1. Okay, good. And I++. Good. So let's try to print the new line. Bro, come on. There is the problem. I set here new line flag and here also new line flag. I am so sorry guys for this. I am so sorry. Okay, this is my fault. Okay, so new line here the escape flag. Okay, so here copy and paste right here. I am so sorry guys. Okay, so make again and -n. Okay, for example here -e. Let's see. Good. Now let's continue. Now we're going to handle the new line flag. Okay, so we're going to go down here and we're going to do an if condition. So if what? If let's see if the new line flag, so let's copy it. If the new line flag is not equal to 1, then please write for me a new line right here. Okay, so new line right here. Good. So let's remove this printf. Good. Make, for example, we don't have anything. For example, we don't have no flags, so cut -e to say if there's a new line or no. We have new lines. Okay, sorry, I need to make it outside the while loop. Let's make it outside the while loop, where Yep, outside the while loop right here. Good. Make again, and as we can see, there is a new line in the end of this output. For example, let's do minus n. We don't have no new line. Okay, now this is so easy. Now let's handle the minus e flag. Okay, so let's go here. So basically, as we know, so to print the escape sequences, they have a backslash before them. For example, backslash g, backslash f, backslash v, backslash n. So this is the flags that I'm going to implement in this echo. Okay, so we are going to see if there is a backslash, then we are going to enter an if condition to see if there is a t after it, or f, or v, or something like this. Okay, so let's continue. So we're going to do v main.c. Okay, so here I'm just not going just to print, but I'm going to do an if condition. Okay, so let's see. Okay, inside here I'm gonna do an if condition. Okay, so if the AV, so let's make just, I love spaces. Okay, so I'm just so sorry guys for the spaces. Okay, so let's remove them a little bit. Good. AV of index I of index g is equal to what? Backslash, like this. And there is another if condition, which is I'm gonna show you guys. For example, let's say we have hello world backslash n and this. Also, we need to handle it if there is two backslash like this. We need to print just one of them. For example, let's try to print them and see it's gonna be printed or not. So it's automatically printed, so we're not going to handle this case. So now we're going to see if the character is equal to backslash or not, and also if the AV of index I of index g plus 1 is not equal to backslash also. Okay, because we need to find a letter, for example T, V, F, or something like this. Okay, so we're going to do if condition. So if the AV of index I of index g plus 1, the next character, is equal, for example, to T. Okay, then we're going to do right. So simple, just 1 and backslash g and 1. Good. Then we're going to do g plus 2. Why g plus equal to? We're going to go 2 steps forward, because we need to move to the next. For example, I'm gonna explain to you. So here, for example, we have minus t right here. We are right here in the backslash. So here we need to go 2 steps forward. We need to step this backslash, and also to step this escape letter. So we don't want to print the escape letter, we want to print the character after this escape letter. Okay, so let's continue. Vim main.c, and let's continue like this. So then we're going to do continue. So go to the next loop, continue like this. I guess I write it well. Continue like this. Okay, then we have else if, the same thing, and another else if. So we just copy it like this. So copy and paste right here and paste right here. Okay, so else if AV of index I of index g plus 1 is equal to what? To backslash n. Then we're going to write what? The backslash n 1. Then we're going to copy this g plus 2. Also we're going to go by 2, to step forward by 2. Okay, good. Then I'm going to remove some spaces, and here we're going to copy this right here, also here, and good. Okay, so let's remove the spaces. and also this. Okay, so let's continue. Else if AV of index I of index G is equal to what? Is equal to for example V. Okay, let's remove this, and here is the AV of index I of index G plus 1. Don't forget the plus 1. Okay, the next character is equal to what? To V. For example, here I'm gonna do V, here F, and I think here G plus 1. So here the if condition, if we have a backslash and the character after this backslash is not a backslash. Okay, so here this is the condition for the backslash, and if the next character is not a backslash. Okay, so we're going to do here is if condition, else if. So for example, just do else, just please write. Okay, so write, let's just do write and 1 the address of AV of index I of index G 1 in a simple way. Okay, so this is the -e flag. It's so simple. Okay, I see that it's so simple for you guys, so let's try to make a lot of problems. Okay, here I forget the AND operator, so AND. Okay, what is next? Okay, yep, semicolons. Okay, let's do it. So here semicolon, also here, also here. Good, make everything is well. Good. Now let's do our flag, for example -e. Alright, there is the problem. No, it's so good. For example, let's do -t. Is not working. Alright, let's do GDB and see what is the problem. Lay n, enter, break at the main, and run -e, for example, and /t, for example. Okay, good. For example, word. Good. Now we have n. Okay, n, for example, like this. Alright, why? Okay, so I'm going to enter. So let's print parameter of index I of index G. Sorry, the AV of index I of index G is equal to L. So we passed the backslash. Why? I don't know why, really. Let's run again. Okay, let's do it again. Run -e, and for example, hello \n and word. Yes, and okay, good. AV of index I of index G. Okay, AV of index I of index G. Alright, so he passed the backslash. Why? Really, I don't know why. Alright, so while the AV of index I of index G is equal to the backslash, then alright, let's do like this. So for example, let's do and quotes like this. Now it's work. Yeah, I know. So the shell, when we don't do a quotes, it remove this backslash. Okay, so if you want to do backslash without this double quotes, you need to do double backslash. So like this. Now it's gonna work. I forget this information. Okay, so now let's continue. For example, n, good. For example, let's do backslash to work properly. Okay, so let's remove this. Good. Minus f. Alright, there's the problem. So let's do minus f is equal to f v. So where's the problem here? So alright, where's the problem? I don't know. For example, v. Good. Where's the problem of f? Why there is a problem in the f backslash f g plus 1? Right, 1. Let's do it from the beginning. For example, like this. Right, 1 f. Good. Now make v is working well, f also is working well. Okay, now we need to do if condition. So for example, as we see, if we didn't do the minus a, it's gonna work. Why? Because we need to add an if condition right here. So and okay, and sorry, let's do right here, and the escape flag is equal to 1. Good. So make is not going to work, and minus e is gonna work. Okay, alright my friend, now our best part, which is assembly. So let's create a file, for example vim.asm. so let's do section.data like this, and let's go down here and let's do section.text like this, then global start like this, and start label, and of course our famous label which is done. So we're going to move ix16 for the exit Syscall, then move RDI 0, then Syscall. Alright, so let's do a comment here. Let's do, for example, exit Syscall like this. Alright, so let's break down what we are going to do. Alright, so as we said, we need to handle 3 things: the flags and the redirection and printing the argument. So now we're not going to use the same order that we used in C to write the code. We are going to flip. For example, we are going to check the flag in the first, then check the redirection if there's any greater than operator, then in the last print all the arguments. Alright, so let's get started. Alright, so just to keep in mind, if you don't know like how functions work, how local variables, I mention you to go and watch my video about how functions are working and how local variables work, because we are going really to need them. Alright, so we are going to start. We are going to do move. We are going to save in the rbx the RSP. Alright, so we're going to dereference the RSP to take the argument counter. I talked about this in previous video, how we can take the argument counter and the argument vector in assembly. Alright, so I'm going to do a comment here, taking the argument counter like this. Alright, then I'm gonna load in the R12, for example, I'm gonna load the argument vector, which is the base pointer, so RSP plus 16. So RSP by itself is pointing to the argument counter in the first of the program. Alright, then RSP plus 8 will give us the name of the program, and we will not use the name of the program because we are going just to skip it. So let's from the beginning, let's skip it from the beginning. Alright, so we are going to do RSP plus 16 to get the second argument, which is like in our work is really the first argument. Okay, so let's continue. We're going to do a comment here, taking the base pointer of the let's say argument vector like this. Alright, then we're going to do something. We're going to decrement the rbx. But before this, let's skip this part. We are going to check if the RBX is equal to 1, because if the argument is equal to 1, we need to for example, just to show a message to the user, please enter some data or something like this. So we're going to compare, is the RBX is equal to 1? If yes, jump equal, for example, enter input. Alright, so we're going to create a label right down here like this. Right, so move RX1, move RDI1, and move RSI, enter input message, then move RDX, let's say enter len. Alright, then let's say Syscall. Alright, so let's copy this and let's go up here and create variable right here, define badge, let's say Syscall. Alright, then we're going to use please enter some data, or let's say some input to be more specific, some input like this, then like this. Alright, so I'm going to copy the enter len and I'm going to paste it right here. So AQ like this, dollar signs minus first of the message. Okay, then we are going to continue. Right, so for example, let's do here jump in the else if condition, jump to done, and let's test our program. So NASM, I think there is a problem. Yes, in the line 14.7 we have a warning, label alone on a line without a colon. Alright, so let's see in the line 47 we have Syscall, we forget an L. Alright, so NASM again, link again, and for example let's enter just the name of the program. We have a problem here, Syscall, please enter some input. For example, let's add some data, for example no message. Okay, so good, we are going well. Alright, now as I told you guys, we need to decrement the argument counter. Why? Because we are skipping the name of the program, and as we said, the name of the program is counted in the argument counter, right? So we need to decrement the argument counter. So here we are going to do decrement the RBX. So decrement RBX will decrement the argument counter by 1. Right, and so then we can set the variables where they will loop on the argument vector. We will start them from 0. Alright, good. Now let's continue. We are going to jump to done. In this else condition, we are not going to jump to done, we are going to do call main. So I'm going to call our main function, and here I'm going to do a modification. So I forget that I need to set the argument for this main function. So here, as we know, every function need argument. Alright, and the argument for the main function are the argument counter and the argument vector, and we need to pass them in this register, which is the RDI, RSI, RDX, RCX, and so on. Alright, so we are going to move in the RDI register the argument counter, and in the RSI register the argument vector. Alright, then we are going to take them in the main function and store them in the local variables. Alright, so for example, let's open our C code to compare some things. Alright, so I'm going to change the background. So I hope you guys like the background here. So I'm going to open the C code to compare. Alright, so we're going to do cut and main.c. Alright, so as we see, let's make it more smaller, for example, and let's do another cut. Okay, so as we can see, in the main function, as we can see here, we have the argument counter and the argument vector. Alright, and the data or the local variables for this function are 1, 2, 3, and 4. Alright, so we need 4 variables. Alright, each variable will take 8 bytes. Alright, then I guess I need another variable for setting like the start of the loop, because as we know, if we have, for example, some flags -n or -e, we need to step them and set the start of the loop. So we're going to need 5 variables. Alright, so let's do a calculation here. So let's do 5 multiplied by age will give us what? Sorry, let's do clear. 5 multiplied by age is equal to 14. Alright, and that's it. Alright, so we're going to call our main function. And set, for example, let's do something. I'm gonna do this, our main function. Alright, then I'm gonna do like this right here. Alright, then I'm gonna do main label, and let's do some space here. Right, and let's remove this space. Okay, so we're going to do push RBP, move the value, the RSP pointer in the RBP, then subtract from the RSP what, let's say what we said, I guess 14. Yeah, alright, 14. So let's store our values. So we're going to store, or are going to move, let's make store, let's do a comment here, store the parameters in the stack frame. Alright, we're going to do move, for example, let's say in the RBP -8. Alright, we're going to store the RDI. So storing the argument counter. Alright, like this. Then we're going to store where in the RBP -16, the next block of memory. Alright, we're going to store the ISI. So we're going to say what, let's do some comment to make them correct, like this, and space here, and another space here for you guys, like this. So storing, I am so sorry for my English. Alright, storing the argument vector. Alright, good. So we stored the argument counter and we stored the argument vector. Good. Now what we need to do, now I'm gonna call the check flag function. So I see that in an assembly, in the flow code of assembly, I'm gonna call the check flag function in the first. Alright, so the check flag function needs some parameters, as we can see here. Need the argument vector, need the address of the new flag variable, and also need a pointer to the escape flag variable. Sorry, why a pointer? Because as we said, we need to change the value here, not the value just in this function, right? So what we're going to do, we need to set the parameters or the arguments for this function, right? So let's do it. So first thing we're going to do, set the argument for the check flag. Let's do some double quotes here and double quotes here for you guys, function. Alright, let's do it. So we're going to move in the RDI something, and move in the RSI something, and also move in the RDX something, and also move in the RSX something. Alright, so in the RDI we're going to move the argument counter, so RBP -8. Good. Let's do a comment for you guys again, sending the argument counter. I really love coding in assembly. Alright, so let's continue. So we're going to do RBP -16 like this. So here we're going to do, and let's do some space for you guys. Right, now going sending the argument vector like this. Alright, then in the RDX register, what we are going to set, we are going to send the RBP -24. So the RBP -24 will be the place for example, let's say it's gonna be the place for the new line flag, the new line flag. Alright, let's say a variable for you guys. Okay, so here what we're going to do, We are not going to do move, because move will move the actual value in this place, but we need to pass the address of this RBP minus 24. We need to pass the address of this block. So simply we are going to use load effective address, okay? And here also load effective address. So we are going to pass what? The next block, which is the RBP minus 32. Alright, so we are going to do what? We are going to do escape flag variable. Good. Let's change this for like to say address, right? And here let's do sending, and here let's do sending. Right, not variable, but the address to be more specific. Okay, I am so sorry for my bad English again, guys. Alright, let's continue. So now we set our argument. Now we need to call what? To call a check flag function. So we're going to do check flag func. Alright, like this. Then we're going to go up here and simply just creating a function, nothing fancy. Alright, so we're going to copy also this and paste it right here, and let's do our check flag function. Good, everything is good. Alright, everything easy. We're going just to do push RBP, move RSP and RBP, make the RP points where the RSP points to. Alright, I explained this in the previous video. Alright, then we're going to subtract. Alright, so what this function, or how many bytes this function need, let's calculate. Alright, we have 8 plus 8 plus 8 plus 8, so we have here 8 multiplied by 4 is 14. I guess. Yep, I am really bad at calculation, guys, trust me. So 8 multiplied by 4, 32. As I said, so here we need to set 32 bits. Alright, that's it, I guess. So we're going to subtract the RSP 32, let's say here 32 bits. Alright, so we're going to do what? We're going to do check loop. So let's say just check arc loop. Alright, but before this, let's save our argument, or let's save our parameters in the scope of the function. Alright, so we're going to do save the parameters. Let's just say params like this, and let's save. Okay, save params in the stack frame like this. So we're going to move again in the RBP minus 8 what? We're going to move the RDI, saving the argc. Alright, the argc is the argument counter. So move again in the RBP minus 16 what? The RSI. The RSI what? Is saving the argv. Please guys, argv is argument vector, argc argument counter. Alright, just to notice. Alright, so in the RPP minus 42 we need to save the new line flag. Alright, so we're going to move in the RBP minus 24 in the stack frame of this function. Forget this. Here we just taking the values from these registers. Alright, so we're going to take what? The RDX, taking the address of new line flag. Right, then what? Move again in the RBP minus 32 what? Move the RCX. Alright, good, no problem. So we're going taking here. I guess I'm gonna need guys, here I'm gonna need 48 bits. Alright, because I need more more variables, I guess. Alright, so here we are going to save in the RPP minus 32 what? Taking the address what? Of the escape flag. Good. Now let's set our registers. So I'm going to set r8 to 0 and move r9 to 0. Good. Now what we are going to do, we are going to compare the r9 with let's say let's move for example in the r12, or let's remove for example in the r14. For example, we are going to move the argument counter, so rpp minus what, minus 8. all right, saving, or let's say moving in the r14 the argc. all right, good. So we're going to compare is the r9 is equal to r14 or yet, in order to continue or to end this outer loop. all right, so if yes, jump equal to check flag end. So in the check flag end, what we are going to do, just I'm going to save, I'm going to add RSP 48 to clear the stack, then pop the RBP. Let's do some space here and do return. Alright, let's do some space here. Alright, good. So now we need to start our code. alright, so we need to take argument by argument. Alright, now we need to loop on the argument by argument and check if this is equal to minus n or minus e using the star comparison. So first thing, let's load or move in the r12 what, the rbp minus 12. alright, moving base pointer in the r12. alright, so I'm going to move in the r13 what, the r12 plus what, plus the r9. Imagine this r12 plus r9 is like AV of index I. The I is the r9 and the AV is the r12. alright, but here there is a trick. We need to multiply by 8 because each component or each block in the memory is containing of 8 bytes. So to move to the next block, where is the next argument, we need to add 8. right, good. Then we have the pointer to the string, so we need to dereference this pointer in order to get the string in this register. So I'm going to do what, move in the r13 to the referencing of this pointer. alright, dereferencing the pointer. alright, good. So now what we need to do, we need to call the star comparison in order to compare this with the minus n or the minus e. alright, but first let's create a variable for them. alright, so we're going to do for example new line flag, new line char for example, will equal to 10 because the ASCII of new line is 10. Then null terminator, then escape char will equal to what, will equal define byte, sorry I forget it, to 9, and here okay, like this. good. Now define byte. alright, so now we need the star comparison. I'm not going to make it from the ground, I'm gonna just say to ChatGPT to make a one for me. So we're going to do, alright, so please make for me. right, so come on bro, so please make for me a star comparison in assembly which is return either -1 or 0. alright, let's do it. So we're going to copy this like this and we're going to continue our work. alright, so I'm going to paste right here. So I guess I forget something. Yep, the name of the function right here. alright, so let's just make it like this and let's do a comment. For example, let's say let's copy this and paste it right here. right, so let's do So let's do SR comparison like this. Alright, so this is SR comparison. It returns 0 in the success when these two strings are equal to each other, -1 in the fail. Alright, so here we need to call the function, and to call the function we need to pass the two strings, and we said each function it takes the argument in first argument in the RDI, the second argument in the ISI. So here we are moving the first string in R13, but now we need to save it in the RDI. So RDI like this, RDI, same thing, just we change the name of the register. Alright, then here in the ISI we are going to move what? The new line char. Alright, like this. Then we are going to compare, call SR comparison. I guess this is its name. Let's just copy it. Alright, so the SR comparison will compare these two strings, and in the success it's gonna return 0. So we are going to do an if condition here. So compare the RX, so each function the return value it returned in the RX register. So we're going to compare it with 0. So if it's equal to 0, then we're going to jump what? Jump equal to set a new line flag. Alright, so we're going to set, or we're going to jump to a label called this. So in this label we're going to take the address or the pointer that point where is the new line flag variable in the int main. So we're going to move, for example, in the R10, I don't know, the RPP minus what? Minus 24, sorry. Then we're going to dereference this R10 and save init 1. Alright, so we're going, so I'm gonna, so it's like I am saying please load or move the address in the R10, then dereference this address where it's point and save init the number 1. Then we're going to increase what? The R9 and jump again to the check arg loop like this. Right, let's make some space here like this. Alright, then we're going to continue. For example, if this condition is false, we need to do the same thing. We're going to move, we're going to copy this and paste it right here. So move in the RDI, the R9, then we're going to dereference and move it also in the RDI. Then here in place of the new line we're going to do escape. Alright, so escape, I hope I write it well. So escape, let's copy it for security. Alright, like this, like, bro, come on. Alright, then if the comparison is true, we're going to jump equal to what? Set escape flag, the same thing. Alright, so we're going to do here like this. So okay, same thing, move R10, what? RBP, I guess minus 32. Yep, minus 32. The pointer of the escape flag variable. So I'm going to dereference this R10 like this and put number 1. Then increase the R9. Then what? Then jump to the check arg loop. Alright, like this. Good. Now let's continue. By the way, I guess everything is well. Alright, so let's do a revision. So in the first thing, so from the beginning, have the start label, move the RSP in the RDI, the arguments vector in the ISI, then call the main. Here, when the call the main will execute, we need the return address, or the return where we are going to continue executing the work, or the code, sorry. So here, when the call main or the main function will end, it will return here, and it will find the SR comparison. We don't want to get right here after the main executes. Okay, we need to jump where? To done. Alright, just to know this. Then we call our main function, push RPP, subtract 14. Alright, call check flag function, jump in the end please. Alright, good. Alright, let's do NASM. A lot of problems. Good. In the line 29 we have instruction not supported. Good. Let's see what's going on here. Push EBP. No, bro, assembly 64-bit please. Alright, so let's copy this. Good, and let's remove this and remove this. Alright, good. Let's remove this and let's do str comparison. Good. Alright, let's continue. We have in the line 18.7 we have operation size not specified. Good. Let's see what's going on here. We have here, in the line, here we are dereferencing this pointer, right? And we are moving a value to this pointer where it's pointing to. Okay, so we need to know, or the system or the CPU need to know how many bytes you are going to move to this place. So we need to specify. So we are going to do here bytes, and here also we are going to do what? We are going to do bytes. So let's do NASM. Alright, simple and not defined. Good. In the line 129, okay, in the 129 jump and done, not end. Sorry guys. Done. Right, I guess also here we have here what? We have here jump done. Alright, let's do NASM. I guess there is a sig fault. I feel it. Alright, let's see. So for example, sig fault as you said. Alright, gdb break the main, and let's do run. For example, hello world, and let's do, for example, here we have -n -e, for example. Alright, so ni, as we see here, we are saving in the RDI and RDX the parameters, the arguments for the check flag function. We are calling it right here as I to jump or to dive into the function, and I like this. Good. As we see now, the R14 will equal to the argument count. As we can see, R14 is equal to 0. Now is equal to 5. Good. Then here, as we can see, we are comparing. The comparison is false. Then in the RDI register we have a pointer to the pointer, which is a string. Then now we are going to the reference. Oh, here's the problem. Why there is a problem right here? Because the R12 not containing anything. The problem in the R12 not containing the argument vector. So let's do it again. Let's do run, and let's do an I like this. Press I, and I. So here's the problem. RPP -0 XC. Alright, why? Where is the problem? Yep, this is the problem. There is the problem right here. Okay, let's see why. Let's go back to our function and let's see. Bro, 12, come on. 16, bro, come on. Stupid problem. Alright, segmentation fault again. Come on, there is no problem, right? There's no problem. -n -e, hello world. So we have here ni, deep dive into the function with si and ni. Let's continue, right? So as we can see, we have in the R12, okay, pointer to the string. Continue. Then here we are saving in the RDI what? The pointer, which is the -n, right? Good. In the ISI we have the new line. we don't want the new line. There is a problem. Okay. We need the flag minus n, not the new line. I am so stupid. Alright, so let's do here minus n and here minus e. Alright, sorry guys for this. Let's do a check. Minus n minus I. Alright, good. Let's do NASM. I guess there's also the sig fault. Yep, I knew it. Break at the main, run minus e minus n, hello world, ni, come on, fast, ni, good, r12 is pointing, good. Alright, the RSI equal to minus n, but the RDI, as you can see, point to nothing. There is the problem. Here is the problem. The RDI not pointing to nothing. So, yep. Alright, there's a problem. Let's do it again. And let's see where's the problem. Alright, so let's do SI like this. And I, so the R12, okay. R9 is equal to 0. So 0 multiplied by h is 0. So we are saving. Alright, so we don't need to dereference the RDI again. I am so sorry guys, because when we did the bracket and the R12 plus R9, we already dereferenced this pointer and get the string. Alright, so this is the problem. We don't need to do the other dereference. So we are going to remove the second dereference. Alright, good, like this. Now let's do NASM. I guess there is some. Now let's do NASM link, and I guess there is some problems. I guess I knew it. No problem. Alright, so break at the main and run minus e minus n, hello world, ni, si, ni again. Alright, so the R12. Alright, good. The comparison is false. Good. The comparison is true, as we see the Rx is equal to 0. Good. Set escape flag. Alright, so now as we can see it's equal to 1. As we can see it's equal to 1, the escape flag. Alright, then we are going to increase the R9 and we are going to go up here. Alright, minus n, yep, it's true. The Rx is equal to 0, as you can see, and set new line flag. Good. So 1 1. Right, this is the addresses of these variables, and this is the values. Check arc loop. There is the problem. Yep, there is the problem. So here, as we can see, I guess there is a problem, guys. Here we decremented the RBX. Yep, I am so stupid, guys. I decremented the RBX, but I am saving the argument counter in the RDI. So sorry guys, let's decrement the RDI, and now let's do NASM link. Good. What was the problem? Let's do RBX and let's see what was the problem. Right, so NASM link, and let's do GDB again. Sorry, no, GDB. So break at the main fast, and let's do run minus e minus n, hello world, and let's do ni, si, ni like this. So let's continue. So as you can see, the two flags are equal to 1. Right, good. The R9 is equal to what is equal to 2. R14 is equal to what? Equal to 5. the full argument. As we can see here, we have what we have 1, the name of the program, 2, 3, 4, 5. All right, good. So for example, here, as we know, the argument vector is starting from right here, so +1 will point right here, +2 will point right here, +3 will point right here. So the problem will happen when we want to execute +4. So +4 is equal to null. So here is the sick fault, and let's see it. All right, so let's do ni. Let's continue. Good. Now let's do an I like this, and let's see. So we have hello and -n. Good, good, good. Everything is well as now. Alright, let's continue. The R9 now is equal to what? Equal to 3. Alright, now we are moving in the RDI what? We are moving word, the last argument, guys. Alright, so here we are going to continue. We are going to continue. Right, then we are going to increase what? Increase the R9. Alright, so now we're going to increase the R9. Let's do an I, and let's see. The R9 now is equal to 4. Alright, 4 is equal to null. So here the problem will happen. In the RDI, we cannot do R12 plus R9, so the RDI will equal to 0, and we cannot pass 0 to the star comparison, and here will be the sick fault. Alright, so this is why I need to decrement the argument counter. I hope you understand, guys, this. Alright, so I'm going to do here RTI, not RPX. Alright, so here, guys, we have the first condition, and here we have the else if condition. So here, guys, just to know, we have the first condition. Alright, so when we compare the string with the -n, and here we have the else if condition when we compare the the string or the argument with -a. So here we need to do the else condition, which will jump where? To a check flag end. So like this. So I'm going to compare, not jump, check flag end, and we are going to save the R9 and the RX, because we need where the loop where it will start, because we don't need to print again the -n or the -e. Alright, we need to skip them. So we are going to move in the RX R9, saving where the index stop to do not print the flags. Alright, guys, I hope you understand this. Let's continue. Alright, so here what we need to do, so here we need to take the start of the next loop, and we need to save it where? We need to save it in the stack. So I'm going to reserve, for example, here 56. Alright, just for ensuring we have more space. Alright, so we're going to move where? We're going to move in the RBP minus the next block, which is 14. Alright, we're going to save what? The RX. So as we said, the return value of any function is in the RX register. Right, so we're going to do saving the start of the next loop. Good, let's continue. Then here what you need to do. So now we are going to continue, and we are going to do what? And we are going to go right here where we need to check if there is any redirection. Right, so here we are going to do move R9 0, and we are going to go jump, not jump, just dot operator. This we are going to name it operator loop. Alright, so in this operator loop we are going to, for example, compare, and alright, here we need to move in, for example, the R14, we need to save the argument counter. So RBP minus H. I don't need to explain this to you guys, alright? So I'm going to move the argument counter in the R14 for the loop. So I'm gonna do a comment for you guys, saving the argument counter. Good. Then we are going to do what? We are going to do compare R9 with R14. Good, nothing fancy. Jump equal if it's true, and operator, or let's just say continue function. Right, so let's do continue function. We are going to continue our main function like this. Alright, good. In the else, we are going to move, let's see, I need to move here. I love moving the argument vector in the R12 register, I don't know why. Alright, so I'm going to do here, move the RBP minus 16. Alright, not saving, please, here not saving, moving. I am so sorry guys. Moving the argument, and here moving the argument vector. Good. So we're going to move in the R12, right? We're going to dereference the R2, so here R13, we're going to dereference in it the R12 plus R9, as we said, multiplied by 8. And we are going to do what? We are going to compare what the we're going to dereference the R13, because as we said, the string or the name of the string is a pointer to the first character. So here in the R13 we have the pointer, we have like the name of the string, right? And if we dereference this R13, we are going to take the first character in that string. Then we are going to compare it with this character. Alright, if yes, jump equal to open file. Alright, good. Else we are going to increment the RH. Good. And no, R9, sorry guys, R9 like this. And jump again, where? Jump to operator loop. Alright, so I'm going to do open file. So in the open file we need to do what? We need to do open file will be right here, up here. Alright, will be up here, and simply just this sentence. Alright, just and jump to end, nothing fancy, and he also jump to end. Alright, so let's do some revision. We end our check flag function. So we did save the RS in the RPP minus 14, right, which is the start of the next loop, which will be the loop of printing, the last loop. And we move 0 in the R9. Let's remove this, and we remove the argument counter in the R14, the argument vector in the R12. We're good. Operator loop label, compare the R9 with the R14, jump equal to continue function if this condition is true. Move in the R13 the R12 plus R9 multiplied by 8 to get the next argument. Then compare the dereferenced string to take the first character by this operator, right? If true, jump equal to open file. Else, increase the R9 and jump to operator loop again. In the open file we just sorry guys. Alright, let's do it. In the open file we're just going to print this enter input message, alright, and jump to end. Alright, let's do it. I guess I feel there is some sick fault, right? Alright, we have in the line 136 operation size not specified. Good, I love problems. Alright, let's see. Yep, as we said, we need byte. Alright, then I guess here we need to do done, not end. Come on, sick faults. Alright, operation loop not defined. Alright, let's go down here and let's copy this and let's paste it right here. Good. Good. Link. There is no sick fault. Good. Let's do this, for example, hello. It's working well. Good. So it went to the open file label and it worked. Alright, let's continue. Let's open a file. Alright, so now what we need to do, let's go to the shell. So now what we need to do, we need the R9 will point right here in this place. So we're going to increase the R9 to point to this place. Then we're going to take this argument and pass it to the open file function and open this file. Then we're going to call the dub2 function, a syscall, sorry, and it's going to do its work with the file script. Alright, let's continue. So vim -asm, let's go down here. Alright, so in the open file we are going to, as we said, to increase what? To increase the R9 like this. Let's continue fast. Here let's do open Syscall. So we are going to do move, come on fast, move rx2, I guess. Here we need to move RDI, here move RSI, here move RDX. Alright, good. So I have the register for Syscall. So in the first register we have the Syscall number. I just need this. So the number for creation and read in the file we need 0x42, because we need to handle if the file is not created or is not in the directory. Alright, so we're going to move where in the RSI we need to move 0x42, and for the permissions of the user, right, read and write. Good. And for the RDI we need to take the string or the argument, which is the name of the file. Alright, so we're going to do what? We're going to do R12 plus R9 multiplied by 8. Good. Then we're going to do syscall and we're going to compare the Rx with 0 if jump less to open error. Let's say error open file. Good. Then we are going to create a label. Error open file will be down here, right, and it's going just to exit. Right, so just, for example, let's say something, for example, let's say a message, for example, error open message we equal to define about we cannot open this file, for example, error open len will equal to eq $signs minus this. Right, so let's copy these two things and let's go down. Alright, and let's paste them right here and let's start. Alright, so let's do move rx1, move rdi1, move rsi, watch the error open message. Alright, like this. Then we have move in the rdx, what we need to error open len, like this. Then we are going to remove this. Thank you very much for your help. I'm gonna delete you like this. Alright, here I'm gonna do jump to done. Alright, then here we are going to do syscall. Alright, so this is in the case of we cannot open a file. Alright, so if yes, we are going to do what? We are going to call the dub2 syscall. dub2 syscall. Alright, so move rx, I guess what is in the number of the dub2 syscall, I guess is 32, 33. Alright, so we're going to do 33. It will take move in the RDI, the file descriptor, and move in the ISI the number 1. And here we need to save what? We need to save the RX. Alright, so we're going to pass the RX right here. Good. And Syscall. Good. Alright, to test this, we're going to do what? We're going to do move RX1, move RDI1, move RSI. What? We're going to do move, for example, move RSI. Let's say input. Let's copy all this. Alright, let's go down here and paste them right here like this. Alright, error input message. So here, if the dub2 is worked, it's this error input message will be printed or written in the file that we are going to create. Alright, so move rdx watch. Let's do like this, the length. Thank you very much again. Bye. Alright, Syscall and jump to done. Alright, let's do a quick revision. Increase R9, take the string in the RDI, RSI, Syscall, compare, RX, jump. Okay. Good. Syscall, move RX. Good. Alright, let's do NASM. Alright, we have in the line 189. Good. Let's see what is inside here. Yep, we have this. Let's remove it. Link. Alright, let's do cut. So the file was created, but the dub2 didn't work, I guess. Yep, I guess the dub2 didn't work. So the dub2, we passed the RX. Yep, guys, come on, look at this. The RX, I changed the value of the RX. Alright, so here we need to do what? Another thing. So we're going to save the RX, which is the file descriptor, in the local variable. So we stopped as -14. Well, but we can do here a trick. We can pass the RDI in the first, right? So we can just flip this. So you can just do this. Just do this and pass it in the first. Alright, so we can just do something like this. So we're going to save the RX in the RDI first, then change the RX to 32. Alright, then change the RX to 32. Alright, let's continue. Let's do NASM. Clear here. LD, come on, fast. Alright, nothing in the string. Good. So now we change the direction from the std out to the file that we opened. Good, now everything is easy. We are going to go to our last while loop. Alright, so let's continue. Now what we need to do, we are going to decrement the R9, right? So we are going to decrement the R9 because we incremented just for checking the name of the file. Alright, now this R9 is indication for us. What is indication for us? As you can see here, where we are going to stop the loop, because for example, let's say here we have -n and -e. So as we said, we saved the start of the loop. Now we are going to save the end of the loop, so we don't need to print either this or either this. Right, I hope you understand this part really well, my bro. Alright, let's continue. So we're going to do what? We are going to do here like this, move. We are going to move in the RBP -48, the R9, saving the end of the last loop. Good. Now we are going to go to our continue function, and let's get started. All right, for our last loop. So now guys, we need to set our registers for the last loop. So we're going to move R9 0 and move R8 0, because now we're going to loop character by character. All right, then now we need to move in the R14 the end of the loop, which is saved in this place. All right, so move in the RBP minus 48. I guess that the 48 is already stored. No, is empty. All right, good. All right, good. Let's continue. So moving the end in R14. Let's continue. Then we need to move the start in the R9. All right, so we're going to do here what? The RBP minus what? Minus the start, which is, I guess, in the minus 14. All right, in the minus 14, like this. Then as we used in the R12, we're going to move the RBP minus 16. All right, then we're going to do arg, then we're going to do here arg loop, like this. Alright, so in this arg loop we're going to compare the R9 with the R14. Jump equal to arg done. Right, arg done. We'll do what? We'll do just jump to done. All right, in this at this time. All right, so now what we need to do, we need to do another label which called string loop, because it's gonna be label inside of label, because we are looping on characters. All right, so to get inside this loop, we need to XOR each time the array to make it is equal to 0. Let's just do move RH 0 for you guys. All right, then here we need to do move in the R13. We are going to move what? The R12 plus R9 multiplied by 8, and here we are going to move in the AL what is inside the R13 plus RH. Right, so then we are going to compare is the AL is equal to 0, then jump please to arg loop. Alright, else we are going to just jump to print char. Alright, so print char is gonna be right here. We are just going to do move rx1, move rdi1, and here we are going to do load rsi what? The address, because as we said, the right Syscall need the address, not the actual character. So R13 plus RH, then move rdx1, then Syscall. Alright, then increase the RH, then jump again to what? To string loop, like this. Alright. Good. So now here, when this thing will end, we are not going to go to jump arg loop, because in jump arg loop we don't have increased R12 or increased R8 or increased R9. Alright, so we are going to create here a label called what? Called get next arg increase R9 and jump to arg loop, like this. Alright, so we're going to pass here what? Pass the arg loop. Good. Now let's do NASM, no problems. Right, let's do cut. Alright, good. Let's continue. Let's do, for example, let's remove this. Alright, nothing. We have nothing. Let's do why. Let's see why. Let's do gdb break at the main and run hello world. So as we can see, there is no flags. Alright, so let's continue. Here we are searching for the operator, right? There is no open file, so we're going to continue. We load in the R12 the base pointer, R13 it's ticked. As we can see, the R9 is equal to 0. Alright, so like this. There's a problem. Wait, what's happened? I didn't see. Let's do it again. Alright, let's do it again. Alright, in the R14 we saved what we saved in the R14. I guess we saved the end where we are going to stop, right? Then in the R12 we saved the argument counter. Alright, good. Then NI. Alright, let's continue. Jump equal to arc done. Alright, here because there's no redirection, so the R14 is already equal to, so there's no end, because this end variable that we stored, it's depend on the flag. If we not the flag, sorry guys, it's depend on the redirection operator. Alright, so here the R14 is taking 0 because there is no end. We didn't set the end, so there is a problem. This is a logical problem, guys. Let's see the solution. Alright, so the problem was right here. We need to remove this line and add it right here, because in case if there is no operator, this operator, so we will not enter this this label. We will not enter this label, so the end of the loop will not be saved. In one case if just we find that we have the redirection operator, then we can save it in this stack, but else no. So we will make it right here. In case either if we find this operator or not, we are going to save the end in this place in memory. Alright, so now I guess let's try to do, let's save NASM ling. Alright, so as you can see, it print them all. I guess I'm gonna do just a space between them. Alright, so let's do let's go down here. So go down here, and we are going to here move, let's say add in space, move RX1, move RDI1, move RSI, let's just say space, and move RDX1 and Syscall. Alright, so we're going to copy this and go up right here. Then we're going to do space and define byte and null terminator. Right, let's do NASM ling. Good, there is the spaces. Alright, for example, let's do the redirection operator. For example, this is the file got b. Alright. I guess there is a problem in opening the file. I guess. Alright, let's see. Let's do gdb my echo break at the main and write hello world redirection into, for example, file 2. Alright, so ni, let's continue. So there is no redirection. Alright, now we have the redirection. Alright, so I'm going to go to open file. Alright, the file descriptor is 3. Good. Alright, so move RX. This is the problem. Right, so we need to remove this part where we write for test. Right, let's remove this part from here. Okay, like this. And let's remove this part. Good. Let's do NASM link cut B. Please enter some. Right, let's see what's going on here. Alright, we have a decrement. Alright, so let's see what's going on. Why enter some input here? I don't know why. Alright, let's see. GDB break at the main. Let's do break at the main and run hello world and redirect it in the file number 3, for example. Alright, and good. Continue. Now we are going to open and we are going to call the dub2 decrement, and we are going to do the write. So the RSI now is pointing to the character, as you can see here. So let's continue. Alright, now we have the word. Let's continue. Alright, so we're going to, okay, so the R9 is equal to R14, so we get out from this. Right, good. So let's see, let's do file 3. Good. For example, let's do rm all the files. Okay, and let's do like that. Good. Let's add something, for example blah 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 blah, and let's see. Why? Yep, there's a problem, space here. Good. Alright, good, everything is working well. Now we need what? Let's do, for example, without this is working well. Good. Now we need to handle the flags, right? So let's continue. We're going to go down here. Alright, so here we are comparing okay, here we are comparing L with 0. So else we are going to compare the L with what? With this character. If yes, then we are going to jump equal to check flag. So this, in this check flag label, we are going, is this check flag is set to 1 or not. So we are going to do this, and we are going to move, for example, in the, I don't know, we are going to move, for example, in the R12. I'm going to get the escape flag. So the escape flag is in the RBP minus 32. So I'm gonna move in the RBP minus 32. Okay, it's, so I'm going to compare is the R12 is equal to 1. So I'm going to jump equal to check T. So I'm going to check T, and so I'm going to jump to print char. Alright, so in the else, if there is, if the check flag is not equal to 1, then we're going to continue printing normally. Else we're going to go to a label called check T. So for example, in this check T, we're going to check is the next character is equal to /t. Alright, so now we as we see, we did a comparison with the slash. Now we're going to check is the next character is equal to t or what. Alright, so we're going to do compare the L Right, so I'm going to compare, let's say the R13 plus R8 plus 1, the next character, with 3, with T. Jump not equal is, if not equal, then check N, then go to a label where we are going to check for the N escape. Alright, so we are going to compare the same thing, R13 plus R8 plus 1 with an N. Alright, so here jump not equal to where or just jump equal to print char. Alright, so print char like this. Alright, so let's continue right here. So here we are going just to do move rx1, move rdi, move rdi1, load in the rsi. Let's continue, move in the rdx1 and syscall, and let's get the variable name. So we have, I guess we need the variable name, so we're going to do here, for example, the slash g, the g, for example, the g, we are going to do 9. The ASCII number of this backslash g is 9, then non-terminator, then the n ASCII is of it is 10. So we're going to continue. Right here I'm gonna pass the G. Alright, good, I guess it's good. Okay, then I'm gonna copy this and I'm gonna paste it right here, but I'm gonna change here to the end. Alright, now we printed the new line, so now we need what to do. We need to escape the character this and also the character that we checked, so we need to move 2 steps forward. So we're going to do add RH by 2, and also here add RH by 2, then again jump to string loop. Okay, so let's do jump string loop, and here I'm gonna jump also to string loop. Alright, good, good. Alright, let's do NASM. Okay, define byte, we need here the define byte, good, and here also the define byte. So NASM. Alright, in the 212, right, I know where is the problem. So here we need to do, I wanna compare just 1 byte, and here also I wanna compare just 1 byte, then just 1 byte, just 1 byte. Alright, NASM link, and good. For example, let's do -e hello world, and inside this hello world we're going to do 2 brackets /n. Is working well, as you can see, /g is working well. Alright, for example, let's try to do references for a file, for example file 3. Now let's cut this file 3, is working well. For example, let's use the new line, is working well. You can handle in your code the \f, the \v. I just give you the idea. Alright, now we need something in the final, which is what, which is cut -e. We need to let's remove this new line right here. Let's make it simple like this, for example. So now we are going to handle the -n flag. So when the -n flag is set, we are not going to add a new line, else we are going to add a new line. Alright, so let's get started. We are going to do vim main.asm, and in the end, or let's say before the end, right here, what we need to do, we need to do comparison. I guess let's make it more technical. So we need to do arc done. We are going to jump to main done. So here we have main done. It's gonna be, let's say, before this, like this, right? So we are going to add RSP 56, then pop the RBP, then return. Alright, and before it we are going to do something. Alright, we are going to get, alright, here we are going to jump to done directly. Here jump to done, and here we are going to move in the R12. I guess what, the RBP minus 24. Alright, so we are going to do here in the RBP minus 24. Then we will compare R12. Then we are going to compare the R11 with 1, or let's say with 0. So jump equal to print new line. So let's copy this and make it right here. So print new line, just move RX1, move RDI1, let's make it load RSI the N, then move RDX1, then Syscall. And here, for example, we're going to do in the else condition, we're going just to do continue like this. Alright, so continue, and it's good, I guess, right? NASM link, for example, here with minus n there will be not any new line, and when we are going to remove it there will be a new line. Alright, good. For example, let's do here \n. Yep, here why the \n didn't apply, because the shell he removed this. So if you want to pass this \, you need to pass it twice. Alright, so let's remove this cut, and let's G is working well. So this was our video for today, guys. I hope you enjoyed and learned something from this. So really it took me like about 6 days to make this project like this. Alright, so I hope you enjoyed. This is our assembly code, about more than 200 line, I guess even 300. Then as you can see here in the other side we have our C code, so our C version. So this is our C version, as you can see, like this. Let's make it more smaller. So that's it. This is our video for today. See you in the next Linux command that we are going to implement from 0 using assembly and C. And of course, for reverse engineering, I'm going to come back for reverse engineering in these days. Alright, so stay tuned. See you there. Peace.